共赢。电之所及，心之所向，一路同行，通达五江。四方股份，踏踏实实做实业，认认真真创品牌，致力于成为拥抱活力和值得信赖的国际一流企业。四方股份，踏实而立，智创未来。
Okay, good afternoon, ladies and gentlemen. This is Sam, and today it's my pleasure to make a presentation about Sifang grid-forming technologies. Okay, let's start. So we're gonna follow this content. background, we all know that global renewable energy development will accelerate in the past and will accelerate in the future. So a lot of countries have already make some suggestions and issued relevant laws and policies to target on the carbon neutrality. But the proportion of the high renewable energy tend to be very high, and this lead to a lot of problems to the prevent power system, including reduced inertia and decreased frequency stability. We all know that the thermal generator can provide inertia, but the traditional grid-following PCS cannot. And when the low inertial system also limited for the active power, right? And the second one is decreased short circuit radio and voltage stability. Third one, like greater resilience. We all know that the wind and solar cannot be independent source. So the Iceland grid and the microgrid all need to adopt like grid-forming technologies. The last one is broadband resonance, just from the power electronic devices and the AC coupled system. So some people may ask, what is grid-forming technology? I just make two diagrams here. We can see from the left diagram is grid following. It just perform like a cousin source, right? Just follow the grid frequency and the voltage. We use the PLL, which means a phase-locked loop. If the frequency and voltage fluctuate in the grid following system will follow the frequency and the phase and the voltage. But the right one is grid forming. You can see it just perform like a voltage source, right? So it can construct the voltage with frequency phase, with inner power synchronous loop, and support the rotational, inertial, and system strength adapt to both strong and weak grids, which means no matter the SAI is high or low, it can always operate frequently. And we can see from here, the grid-forming technology applied to power electronics to actively establish and regulate grid voltage and frequency, which is similar to a traditional synchronous generator. We can see from the diagram, we just simulating the synchronous generator physical equation and add the active power loop, reactive power loop, and the voltage cousin loop to make it like a virtual synchronous generator. So what's the characteristics of the grid-forming technology? You can see the first is weak system adaptability. From here, you can see the traditional one, the upper one, right? When the SAI is lower, it will lead to like fluctuation. But for this grid-forming, you can see it can always operate even the SAI is very low. And second, third is voltage and frequency support. Because the voltage just like a voltage source, so it can naturally respond to the voltage and the frequency changes. And here is like a smooth transition between grid connection and off-grid. You can see traditional solution is like that, make some fluctuation between the transition from grid connected to off-grid, but there is no problem for the grid-forming solution. And minimize the risk of wideband resonance issues. We can see from this border plot, you can see the phase curve. It's always performed like a positive damping characteristics. And the last one is AC protection adaptability, which means it can perform like a high similarity to the synchronous machines. And here are the functions about the grid-forming technologies. frequency inertial support, which means it quickly provides like a frequency regulation and inertial support to support the grid, and the voltage support. It can also output a maximum 300% overload current, and the isolating capacity, black start, right, independently establish the voltage and the frequency. The fifth one is power oscillation separation, which means it can perform like a damping control to separate the low frequency oscillation. And last one, it can operate on the low SAR. So how to use grid-forming technology? With that background, the Sifang grid-forming solutions will give you like 3 options. We have 3 products to be used in different scenarios. The first one is Grid-Forming STATCOM. That is traditional solution, grid-forming. And the second one is Grid-Forming SSA, which means static synchronous condenser for short. And it also have another name like E-STATCOM. E means energy STATCOM, because it adopts the supercapacitor on the DC side, which takes the energy to it. The last solution is Grid-Forming BESS, battery energy storage. We can see from here the comparison. From the left, you can see the conventional solution about the STATCOM. It cannot support inertial support and active power, right? It's just output like reactive power. And conventional energy storage, battery energy storage, it cannot output like inertial and short circuit capacity. But in the middle, we can say Grid-Forming SSA. Grid-Forming SSA can output all active power and reactive power and inertial, right? And the Grid-Forming BESS, it can have all the functions like all-rounded, just like a synchronous generator. Okay, here is the first product, like Grid-Forming STATCOM. This is the traditional one. We all know that the conventional Grid-Forming STATCOM with non-energy type has 2 topologies. This one is star connection, right, and delta connection. And on the DC side, it adopts the thin film capacitors. If you need like 300% overload, we will oversize the capacitors on the DC side. And it can also be custom sized to adopt the AC rated voltage from 6 kV to 66 kV. And the liquid cooling system. And so here is a layout, including the reactor, cooling system, and value, and disconnector, and etc. Usually, a Grid-Forming STATCOM are used on the scenario like a steel melting factory or some renewable island. Okay, here is the second product, like E-STATCOM. We call that SSA, right? A static synchronous condenser. It can achieve the external characteristics equal to the traditional synchronous condenser. You can see from the topology, we adopt the full bridge and half bridge and MMC topology for that. The most important thing is that on the DC side, we just adopt the supercapacitor clusters as a device to output the active power into the grid. It can also overload like 3 PU in 10 seconds. And here is the main parameter. It can be used in the voltage of like 10 kV to 35 kV, and the rated capacity can be 5 MW up to 120 MW. And no matter reactive power or active power, it can all overload, and also custom sized. For transient voltage, the response time can be less than 5 milliseconds. If any failure happened in the grid, our E-STATCOM can react quickly to support the voltage up to 90% under 5 milliseconds. And the inertial time constant can be adjustable from 3 to 20 seconds. Even on the SAR equal to 1.0, it can still operate. Okay, the last product is about Grid-Forming BESS. Grid-Forming BESS, just like this picture, including the battery container, right? The right one is a middle voltage integrated system, including PCS and the transformer. And we can see from the right one diagram, we adopt 3 layers from EMS, PMS, and the coordinating controller. All those components are self-resolved and self-produced. So we integrated all those devices into one cabinet to realize better characteristics for the grid forming. Okay, here is a middle voltage integrated system with high efficiency and flexible and footprints and smaller footprint. So here is about technical parameters. Now we have a product like the rated capacity from 750 to 1,500 kilowatt ampere, and this is for like overload. Well, we make it to realize like 3 PO in 10 seconds. And now to make a brief summary, we can see from here, the Grid-Forming STATCOM is just equal to synchronous condenser, right? And the Grid-Forming traditional STATCOM is like enhanced STATCOM because we just oversize the capacitor on the DC side to make it available to be overload. And the last one is Grid-Forming BESS. It can be equal to synchronized generator. Okay, here is about some project reference. This project is about Grid-Forming STATCOM. And here we adopt 100 megawatt STATCOM to support the voltage and the inercent. This is used in Xinjiang company for the 1 million kilowatt wind power system. And here is the Sichuan Energy Ninghai Thermal project. And for this project, we adopt a 5 megawatt hour Grid-Forming BESS system to participate the frequency modulation and the voltage modulation. And here the Grid-Forming STATCOM. This is a traditional one. We adopt 50 megawatt to increase the short circuit ratio in the wind farm. The last one is about Grid-Forming BESS system 2, about this project in Sichuan Yalongjiang River Grid. And for this project, the altitudes exceeding 5,000 meters. We all know that the high altitudes will affect to the heat exhaustion, right? Okay, that's all. Thank you.
Hello? Oh, okay. Hello, everyone. Good afternoon. I'm Xiang Wei, and later I will give the brief introduction about our PCS product. And here is a brief background. To address the global climate change, the carbon neutrality and net zero emissions have become the central policy targets for the nations worldwide. And according to the precision by the International Energy Agency, if all of the net zero targets announced by the countries are fully met on time, the share of the renewable energy in global electricity generation will need to increase to nearly 50% by 2030 and further rise to nearly 70% by the 2050. However, as the share of the solar and wind power rapidly expands in the power systems, their inherent variability and intermittency will pose significant challenges to the grid stability. So to solve these challenges posed by the renewable energy, the energy storage serves as an effective solution. A consensus has been reached among global markets that the energy storage will continue to grow alongside the expansion of the renewable energy in the coming decade. The energy storage installation globally is reached. The global energy storage annual addition reached 110 gigawatt and 300 gigawatt hour in the global area in 2025, and as the inspection by the Bloomberg, the cumulative energy storage capacity in 2035 is expect to reach 2 terawatt and 7.3 terawatt hours, which is 8 times the level in 2025. In addition, the grid-forming the grid-forming energy storage system is also important in the power system, and in Australia and the European Union has proposed some agencies about the grid-forming energy storage, which will have a priority action item, or which is the essential requirement for the grid connection. So that the Wood magazine predicts that from 2024 to 2034, in order to maintain the grid stability, the world will need to add 1,400 gigawatts of the grid-forming energy storage. And later, we will come to our energy storage and PCS products. Actually, Sifang starts our energy storage business in 2009. And we are always focused on the research and development of the core equipment for the energy storage, such as the PCS, the EMS, the battery pack, the BMS, and also the protection control device in the substation. And we have our we have the self-develop and self-product capabilities of all the products in the energy storage system. And for our PCS products, we are focused on the centralized PCS, and our grid following type PCS covers the rated capacity from 1.25 megawatt to 3.45 megawatt. And all the models are complying with the IEC and IEC standards. Also, we have the grid-forming PCS, which capacity covers from 625 kilowatt to 1,725 kilowatt. And the grid-forming PCS is capable of 300% overload for short term. And also, we can provide the integrated medium voltage skid, which includes the PCS and the transformer. And the capacity covers from 2.5 megawatt to 30.8 megawatt. As we know, the PCS is the essential equipment in the energy storage system, which enables the bidirectional energy exchange between the battery system and the power grid, and is capable of the control and management for both charging and discharging of the battery. Our PCS has the following advantages. First, we adopt the three-level ANPC topology, which leads to the high efficiency. We have the maximum efficiency of over 99% and the full load efficiency over 98.5%. And also, we adopt the intelligent forced air cooling method, which leads to the high power density and the small footprint. And also, we obtain the full load operating capabilities at 50 centigrade. It can remain no derating at 50 centigrade. And our PCS has the high protection level of IP65 and maximum C5 anti-corrosional level. And also, we adopt the multi-level software and hardware protection. And the hardware protection action time can be less than 10 microseconds. We also use the long duration and the high precision waveform recording for both steady state and transient state, which is help the maintenance more easy. And we use the advanced software control method to realize the high speed control and the charging and discharging transition time, and also the active and reactive power command response time are less than 20 milliseconds, which leads to the better AGC and AVC capabilities for the BESS station. And for the integrated medium voltage skid, we can provide from 2.5 megawatt to 30.8 megawatt. And the mainly products is one of the mainly products is the 5 megawatt 20 feet medium voltage skid. It adopts the standard 20 feet container so that it's convenient for the transportation, and also we can provide the 10 megawatt medium voltage skid, and also composed of 2.5 megawatt PCS, and also the 13.8 megawatt medium voltage skid composed of the 3.45 megawatt PCS. And the standard size is the 40 feet container. Besides the grid-following PCS, we also have the grid-forming PCS. And as our colleagues described before, the advantage of the grid-forming PCS is to perform the frequency and the inertial support during the frequency change of the power grid, and the response time of the inertial support is very fast. Also, during the voltage fault of the power grid, it can support the active voltage support and maximum 300% reactive current output during the voltage fault. For some projects which are located in the island or in the remote area, the grid is generally weak, and in this condition, the grid-forming PCS can provide the islanding operation capabilities, and also for some microgrid application, it can support the seamless transition between the grid-connected and the off-grid operation. And also, it can support the black start capabilities for the power system. And for the weak system, which SCR is even less than 1, the grid-forming PCS can remain stable operation and also can help to increase the SCR for the renewable power plants. Here is our datasheet of the grid-forming PCS, and it can also reach the full load operation capabilities at 50 centigrade. And our grid-forming PCS has passed all the tests proposed by the industrial standards, and all of the test results meet or even exceeds the industrial standards. And last, we will introduce some project cases. Over the past 3 years, we have taken part in more than 100 energy storage projects, and it carries the different application scenarios, from the renewable energy to the traditional power generation, and the grid side, and also user side and the microgrid side. And till now, our PCS delivery capacity is near to 2 gigawatt. And this is a battery project, energy storage project in Laos. And this is a phase 1 project. We also delivered 16 megawatt and 32 megawatt hour products for another project in Laos. And the energy storage system can realize the peak shaving and the load leveling to reduce the abandonment of PV power. Here is one of our overseas grid-forming projects. It's a 10 megawatt and 40 megawatt hour grid-forming BESS project in Pakistan. And in this project, the PCS can remain the full load capacity under the 50 centigrade, and it can provide the islanding operation to the load, to the mining load. This is a grid side project, and we have supplied the 150 megawatt PCS and also the 300 megawatt hour EMS in this project. And this project this energy storage project can realize the AGC and the AVC regulation for the power grid. And this is a grid-forming energy storage project for the microgrid, which located in Sifang. And in this project, we adopt a new type grid-forming PCS, which is compatible to the high altitude environments over 4,000 meters, and we use the reliable electrical design to keep the PCS node rating under 4,000 meters. And also in this project, the grid-forming PCS is capable of the seamless transition between grid-connected and off-grid mode to keep the electricity used by the end user, and also it can support the black start capabilities. Okay, that's all. Thank you.
Ladies and gentlemen, I'm Chen Zihao. It's my honor to be here to introduce our solution about the source grid load storage monitoring and control system. And I will share, my whole share will divide it into 4 parts. The first is the overview of the solution, the characteristic, and I will dig into more details about the solution itself, including the panoramic monitoring and O&M module. And also the second one is the coordination control and also the forecast and decision-making module. And then I will introduce more details about our special application Microgrid. And I will finalize with my company, which already implements some typical cases in the world. And first, let's look at the trend of the industry. As the global renewable industry proportion already increased a lot, and EU and Asian countries already released their plans for the renewable energy installation capacity. But there's also some challenges we have to face. For example, the large-scale renewable energy integration to the power grid, and also how to get the lower cost and greener power supply. With all these questions, we just sort the scenario into 3 parts, 3 tabs. The first tab is our large-scale hybrid power station, and second scenario is our high energy consuming industries like the hydrogen, aluminum, and also the independent microgrid. The different scenario may have different characteristics, but the demand is similar. Is to build one system which can support the stability, higher renewable consumption, also the grid compliance. And we have sorted these 3 core demands based on the scenarios. The first is the system stability. The renewable power's interdependency clashes with the industry's loads, and also the coordination control is very complicated due to the grid compliance. And the second one is the economic operation. The unstable generation and loads plus the inaccurate forecast cause the power curtailment. And the source load peak value mismatch limits the renewable utilization rate. Also, the auxiliary services and the electricity price market is variable. It's very hard to maximize the whole benefits of the whole plant. And the final one is operation and maintenance. Actually, we can see this large-scale renewable energy plant or this SLGS scenario. There's massive distributed devices, and we cannot using the traditional way to maintain the whole plant. And based the core requirements, we developed this scenario solution. We use this multi-time scale coordination as the core of the whole solution. And the first requirement we can fix is the system stability. which equipped with our coordinated control of the hybrid system, the regulation of the BESS system, also the source load real-time control. The second one is the economic operation, equipped with our power prediction, load prediction, also the electricity market assistant module. We can improve the economic operation a lot. Oh, and the SIF and O&M is a very fundamental but important function. Our solution provides this panoramic monitoring and also the intelligent control system for the whole plant and the equipment, different level O&M. And the solution relies on the products. All these products are self-developed and manufactured by Sifang company. The first one is the EMS SCADA platform. It provides the monitoring and also the plant level, the equipment level, and also the coordinating control, the day ahead and intraday generation scheduling. And also it supports large data integration, more than 10 million real-time analog data, and more than 8 million digital points. And also we support the whole dispatching process based on the mainstream protocol like the 104, 61850, and the model bus. Another key point is our controller. The interface is multiple and is flexible to different protocols. And our programmable logic comply with the IEC 61131. And one single devices support more than 200 subunits. Besides the products itself, we also support these simulation services. Based on our RTDS simulation laboratory, we can do many strategy verification, also the flexibility analysis, and we can run this closed loop strategy before the project deliver. And we can let the project smoothly go online. And next part, I will introduce more about the panoramic monitoring and O&M module. Here is our capability of the whole platform. The real-time analog, more than 10 million points. Real-time digital points, 8 million points. And the whole data is, we can support more than 20 million data points integration. And also we provide the primary and the auxiliary system integration, also the KPI analysis. And here is the actual interface of the whole platform. On the left side of the slide is our general overview, and it can give the direct snapshot of all power generation plan completion rates, and other key performance indicators. And also the plant wheel, we provide this quick abnormal situation detect and reduce the downtime, enhance the whole efficiency of the maintenance. For the equipment level, we have this PV layout, status monitoring, PV block, and also the BESS PCS, BMS level monitoring. Except the monitoring, we also provide the control, the remote control function. Like for all the primary equipments, like the wind turbines, solar inverters, also the BESS PCS, we all support the remotely control. And also for the auxiliary system, we can support this CCTV, fire alarm system, also the environmental controlling system. To make sure the performance of the whole plant, we have this KPI analysis and alarms, reducing power losses, and establish the different way to analyze the whole plant. We can like the generation output, the equipment reliability, also the energy consumption. In some cases, we also provide this digital twin for the whole system. Digital twin plants and substation is a dynamic, real-time replica for the physical plants. It integrates the smart cameras, IoT sensors, also the real-time data, and improve the efficiency of the maintenance. And the second module of our solution is very important. It's our coordination control module. We adopt this 3-layer architecture, and we have the optimization layer for the managed level control. We have this coordination control layer for the second level control. Also the substation control layer for the field control. And here is our wind plus solar and BESS coordination module. With this module, we can achieve the power smooth, also the peak shaving, valley filling, and also we can provide the primary frequency for the fast control. The real-time control of source and load is another advantage of our system. Real-time source and coordination matches the renewable output to the load for stable power supply. For the generation set, we just smooth the whole power fluctuation using this BESS characteristic, the fast charging, discharging characteristic. And for the load set, we have this flexible load management system to keep the whole green energy consumption rate at a high level. And the stability of the system is always the first priority. We have this SIPS system to make sure the whole system contribution is under control. A multiple safety defense line ensures fault recovery and system stability. We adopt the control idea of the regulation, not directly cut the units or the BESS or the load. And here is the last module, the forecast and the decision-making module. First is our power generation forecast. Our power generation forecast module supports the long-term, short-term, and ultra-short-term forecasting based on the data from the weather data platform and also our physical running status. And for the load prediction, we just we just adjust the whole algorithm based on different scenario. For the hydrogen scenario, and also for some scenario like the aluminum, to consider more influence factors like the holiday, the arrangement, the scheduling. After we consider all these influence factors, the accuracy of the whole prediction has improved a lot. Meanwhile, the platform supports the market decision making, the whole process, from the data acquisition to the day-ahead intraday forecast, also the decision making for the market participation. And we also support the review settlement for from the dispatcher to the spot market platform. And a complete closed loop data interaction mechanism is formed between the EMS and the spot market platform, also the dispatcher. And here's the actual process for the Philippine electricity market. And now I want to also show some typical strategy for the whole EMS. The first one is the electricity price arbitrage strategy. Basically, it includes two typical strategies. First is the peak value arbitrage. The best system charge when the price is low, discharge when the price is ahead, and adjust the plans based on the day ahead and also the real-time data price gaps. The second one is our renewable power plus BESS coordinated scheduling strategy. Normally, we just use this renewable power first, store access in the BESS system, and use the BESS to balance the forecast errors. For the BESS system, we also have this specific strategy. First is the circle limitation. The high frequency of the charging, discharging degrade the BESS system a lot. And SOC health management also should be considered to avoid any deep charging, discharging. And now I want to show more information about our special application microgrid solution. As we can see from the left side of the slide, the cost of the renewable energy equipment decreased a lot. And there's more demands like the village, island, factories, and the data center comes to the market. And our clients more focus on the stability, the optimization, the economic, and also the seamless model transfer for this stable and transient control. And here shows the typical composition of the microgrid. And the Sifang company apply the whole solution complying with the IEC standard, covering the planning, grid connection, control, and protection. And we also use this three-layer level architecture. The mainest level to respond to the dispatching command. The second level for the rapid control, and the local level for the equipment level to achieve this millisecond response to the system change. And what we can provide first is our EMS platform. Second is our microgrid coordinator controller, and also our Grid-Forming PCS, which is important equipment of the model transfer. And here is the Grid-Forming BESS system provided by our company, and it serves to keep the strong overload capability and rapidly stabilizing the frequency and the voltage change. And here's also another important core system in the microgrids to support this seamless model transfer. This is our fast switch system, and this system can support opening less than 5 milliseconds, closing less than 20 milliseconds to make sure the transfer procedure smooth. And here's some typical strategies for the microgrid application. Basically, we divide it into three parts. The first is the grid connected mode, and second is our off-grid mode, and also the transfer procedure control mode. In the grid connected mode, we more focus on the time-length power control, peak value arbitrage, VF regulation. And for the off-grid mode, we just use different units as the main power supply. for example, the BESS and also the DG. And for the mode transfer procedure, we provide this black start capability, planned conversion, unplanned conversion, also our synchronized grid connection. And here's some typical strategies we already applied in our controller. The first one is the rotational reserve. We just keep enough reserve of the whole system to make sure any small changes in this system can be achieved achieve this stability of the system. And the frequency control normally falls into three ranges: the stable zone, warning zone, also the emergency zone. And based the status of the system, we apply the different strategy. For the off-grid microgrid, we have this DG as the main power supply, also the BESS as the main power supply. For the BESS, we just focus on the SOC range. And for the DG supply, we often put the efficiency of the whole equipment as the first priority. And now I want to show more details about our typical projects. The first one is our representative large-scale hybrid power station. It is a Philippine Terra Solar power station consisting of 3.5 gigawatts PV plus 4.5 gigawatts hour BESS system. And Sifang provides this SCADA system, EMS system, also the master and slave PVC architecture, and also the PV system. There's another three gorgeous wooden chop integrated wind plus solar plus BESS project. The project's scale is 1.7 gigawatts wind power, 300 megawatts of PV, and 1,100 megawatts hour BESS. It's the first BESS plant in China to reach this gigawatts hour level. And this is another silicon production source grid load storage scenario project. This is China's first SGLS integrated project, and the whole project includes 425 megawatts wind, 120 megawatts PV, also another like the rooftop solar and the BESS system. And it mainly operates in two modes. The first is self-consuming with surplus power fitting to the grid. The second is the generation priority mode. Basically, that's all shared today. Thanks for your listening.